What if we could actually reach the edge of the universe? Would we simply bump into a cosmic wall, or would we fold into another dimension? Let's dive into these intriguing questions. When we speak about the universe's edge, we're really talking about the observable universe's boundary. The observable universe is a sphere around us from which we can receive information. This sphere is approximately 93 billion light-years in diameter. But wait, isn't the universe supposed to be only around 13.8 billion years old? How can we see objects that are 93 billion light-years away? This is where the cosmic light horizon comes into play. The universe has been expanding since its inception. Hence, the galaxies we're observing now are much farther away from us than they were when their light started its journey towards us. This phenomenon is known as the cosmic light horizon, and it limits our observable universe. Imagine it like this. You're standing in the middle of a dark field. You switch on a flashlight and the beam extends outwards, illuminating a certain distance. That's your observable field. Anything beyond that, although it exists, is unobservable to you because the light from your flashlight can't reach it. Similarly, the observable universe is not the whole universe. It's just the part that we can see. The age of the universe limits how far we can see because light from beyond that boundary hasn't had time to reach us. So, when we talk about the edge of the universe, we are essentially discussing the cosmic light horizon. But remember, this is not a physical boundary. There's no cosmic wall or an abrupt end. It's simply the farthest point we can see. In conclusion, the universe's observable edge is just that, the farthest point we can see, not the actual end. But that doesn't make it any less fascinating, does it? After all, who knows what secrets lie beyond the cosmic light horizon waiting to be discovered? Ever wondered what lies beyond this observable universe? Let's dive into the cosmic unknown. Our universe, as vast as it is, represents merely a fraction of the cosmos. Beyond our observational limits lie mysteries that challenge our understanding of nature. One such concept is the multiverse, an idea that posits the existence of an almost unfathomable number of universes. According to string theory, a cornerstone of modern physics, there could be as many as 10 to the power of 500 possible universes. That's a one followed by 500 zeros, a number so large it's beyond human comprehension. Each of these universes, including ours, is like a bubble floating in a cosmic ocean, and each one could have its own distinct laws of physics. Some might be similar to our own, with galaxies, stars and planets, while others might be radically different, with no matter, no stars, just pure energy. Speaking of energy, let's discuss the enigmatic dark energy. It's a hypothetical form of energy that permeates all of space and tends to accelerate the expansion of the universe. You see, the universe isn't just expanding, it's doing so at an ever-increasing rate. This acceleration is attributed to dark energy, a mysterious force that makes up about 70% of the total energy in the universe. We can't see it, we can't touch it, but we can observe its effects on galaxies and clusters of galaxies as they move apart from each other. Now, you might wonder, if the universe is expanding, then there must be some sort of center everything is moving away from. But that's not the case. The universe doesn't expand into an existing space. Instead, it's the fabric of space itself that's stretching, and that's happening everywhere, not just at some distant boundary. While these theories might sound like science fiction, they are grounded in mathematical models and physical laws. Let's consider another aspect. How fast would we need to travel to reach the universe's edge? To start, let's talk about the speed of light. This cosmic speed limit, as Einstein would call it, is approximately 299,792 kilometers per second. Yes, you heard that right, not per hour, per second. But even at this unimaginable speed, it would take us an astounding 46.5 billion years to reach the edge of the observable universe. Why so long? Well, it's because our universe isn't just sitting still, it's expanding, and it's doing so at an accelerating pace. So while we're trying to reach the edge, it's speeding away from us. Astronomers measure this expansion as a rate per unit of distance, known as the Hubble constant. The current value stands at about 70 kilometers per second per megaparsec. What this means is that for every megaparsec of distance from us, space is expanding by 70 kilometers per second. Essentially, the universe is like a cosmic treadmill with the speed cranked up to max, and we're the hapless joggers trying to keep pace. Now, let's add another layer of complexity, the concept of space-time. According to Einstein's theory of relativity, time and space are woven together into a four-dimensional fabric. When you travel close to the speed of light, weird things start to happen. Time starts to slow down relative to someone who is stationary. This is called time dilation. So if we could somehow build a spaceship that could travel at light speed, not only would we have to deal with the universe's expansion, but we'd also have to contend with time itself stretching out before us. Therefore, even if we could travel at light speed, the universe's expansion would always keep its edge tantalizingly out of reach. So reaching the edge of the universe, it's a thrilling thought, but for now it remains a journey beyond our reach. What about our current technology? Could it ever take us to the edge of the universe? Let's consider the fastest man-made object we've launched into space, the Parker Solar Probe. This ambitious project, named after astrophysicist Eugene Parker, is currently hurtling towards the Sun at approximately 430,000 miles per hour. It's an impressive speed, no doubt, but let's put this into context. To reach the edge of the observable universe, we'd need to cover a staggering 93 billion light-years. A light-year, as you may know, is the distance light travels in a single year, which is about 6 trillion miles. So you can imagine the enormous distance we're talking about here. Now, if we were to set off on this cosmic journey in the Parker Solar Probe, traveling at its top speed, it would take us more than 6,000 billion years to reach our destination. That's over 400 times the current age of the universe. Clearly, our current technology is not up to the task, but what if we could travel at the speed of light, you might ask? Well, even if we could theoretically achieve this, the energy requirements would be astronomical. According to Einstein's theory of relativity, as an object approaches the speed of light, its energy requirement and hence its mass increases exponentially. We'd need an impossible amount of energy to propel a spacecraft to light speed. Furthermore, there are numerous technological challenges to overcome. For one, we'd need to solve the problem of time dilation, the effect where time slows down for an object moving close to the speed of light. We'd also need to shield the spacecraft from extreme radiation and interstellar particles, which could be lethal at such high speeds. So while the idea of reaching the edge of the universe is fascinating, it's clear that our journey to the stars is still in its infancy. Our current technology, as astounding as it is, simply doesn't have the capability to take us to the farthest reaches of the cosmos. Given our current technology, it's clear we are far from being able to reach the universe's edge. So, could we ever reach the universe's edge? We've grappled with this question, delving into the enormity of our observable universe, approximately 93 billion light-years in diameter. We've pondered the cosmic light horizon, our observational limit, beyond which lies a realm of infinite possibilities, an almost infinite number of universes. We've confronted the truth of our universe's accelerating expansion, a relentless force that only pushes our goal further away. And we've considered our current technological limitations, the speed of light as our absolute ceiling, which would still require 46.5 billion years to reach the edge of our observable universe. Each point underscores the magnitude of our ambition to reach the universe's edge, a dream as vast as space itself. While we may dream of reaching the universe's edge, the vastness of space and the laws of physics suggest that for now it remains a distant, unattainable frontier.